Imagine you wake up, walk into the kitchen, and discover that your coffee mug is passed halfway through the table. You do not immediately question the nature of existence. You assume the table is broken in a new and unusually ambitious way. But suppose everything you see, including the table, the mug, your hands, and the small stain you have been politely ignoring for 3 years, is generated by a computer somewhere outside our universe. Are we living in a simulation? The honest first answer is that we could be. We have no accepted evidence that we are, and the famous philosophical argument does not prove that we are, despite what a confident person beside a podcast microphone may have announced. To understand the real argument, picture reality as an apartment inside an enormous computer. The people in the apartment experience solid floors, annoying neighbors, and gravity. Outside it sits another world containing the machine that runs everything. The central question is not whether our universe resembles a video game. Almost anything resembles a video game if you stare at it while tired. The question is whether conscious beings like us could exist inside a sufficiently detailed artificial world without knowing it. In 2003, philosopher Nick Bostrom published what became known as the simulation argument. It begins in the future. Suppose some civilizations survive long enough to become extraordinarily advanced. Suppose they gain enough computing power to simulate entire populations of conscious people. And suppose they become interested in running large numbers of simulations of their ancestors. Maybe these simulations are historical research. Maybe they are entertainment. Maybe somebody wants to learn what happened in the early 21st century and accidentally generates 9 billion people arguing about sandwich prices. If one advanced civilization can create millions of simulated worlds, then simulated people could vastly outnumber people in the original world. And if you know only that you are a person having ordinary human experiences, Bostrom asks why you should assume you belong to the small original group rather than the enormous simulated group. It is like entering an apartment building with one real apartment and 10 million perfect stage apartments. If you wake up in a kitchen without knowing the floor number, statistics seem to lean toward plywood walls. This leads to Bostrom's three-way conclusion. Either civilizations like ours almost always disappear before becoming technologically mature, or advanced civilizations almost never choose to run many ancestor simulations, or simulated observers greatly outnumber original observers. That third possibility would make it likely that we are simulated. But the argument does not tell us which of the three is true. This is the crucial difference between Bostrom's argument and internet certainty. He did not discover a loose pixel behind Saturn. He constructed a conditional argument. If advanced civilizations survive, if they can create conscious simulations, and if they run huge numbers of them, then we should take seriously the possibility that we are among the simulated beings. Those are substantial ifs. They are not decorative cushions. If careful uncertainty in badly drawn surroundings sounds useful, subscribe and we will continue examining the walls without licking them. Start with computing power. Simulating an entire universe in microscopic detail might require an absurd amount of energy and information. A paper published in 2025 argued that a universe governed by physical laws like ours could not realistically simulate our observable universe at full physical detail. The required resources would be astronomical, which is an unhelpful word here because the astronomy is the problem. But this does not eliminate every simulation scenario. The outside universe might have different laws. The simulation might reproduce only what its inhabitants can observe. It might generate broad outcomes rather than calculate every particle continuously. Our apartment might contain detailed wallpaper only when somebody looks closely. This is computationally economical, though unsettling for the wallpaper. Then there is consciousness. Bostrom's argument assumes that the right kind of computation could produce conscious minds. Not merely characters that say they are conscious, but beings that genuinely feel pain, embarrassment, hunger, and the need to pretend they understood a menu. That is a major unresolved question in philosophy of mind. If consciousness depends on biological features that cannot be reproduced computationally, simulated humans might be sophisticated puppets rather than observers. In that case, counting simulated bodies would not tell us how many conscious people exist. There is also the problem of counting. Bostrom's reasoning asks us to treat ourselves as something like a random sample from a group of observers. But which group? All humans. All human-like minds. Every conscious being. Every version of you generated for 12 seconds before the computer crashes. Change the reference group and the probabilities may change. The statistics sound clean only after some very untidy decisions about who belongs in the jar. And we know almost nothing about advanced civilizations. Perhaps most destroy themselves. Perhaps conscious simulations are impossible. Perhaps descendants capable of creating them find the idea morally appalling. Running billions of worlds containing disease, grief, and tax forms would not become harmless just because the victims were stored differently. Perhaps advanced beings have better things to do. This is speculative, but so is assuming that the final achievement of intelligence will be an enormous historical reenactment run by people who refuse to go outside. What about evidence from physics? Claims often point to the speed of light, quantum mechanics, or the smallest measurable scales as if they were signs of limited processing power. The speed of light becomes the universe's loading limit. Quantum uncertainty becomes a trick for avoiding unnecessary detail. Empty space becomes evidence that the developers reused assets. These comparisons are vivid, but resemblance is not evidence. A physical limit can simply be a physical limit. Quantum mechanics is strange, but strange does not mean programmed. We should not infer a laptop merely because nature has rules. Scientists have explored whether particular kinds of numerical universes might leave detectable traces. One proposal considered a universe calculated on a cubic lattice and asked whether extremely energetic cosmic rays might reveal directional patterns caused by the underlying grid. That would test a very specific model. Finding such a pattern would be interesting, though it would still require ruling out ordinary physics. Not finding it would reject that model, not every possible simulation. The programmer, if there is one, was not required to use cubes. Recent work in computer science has also tried to define more carefully what it means for one universe to simulate another. This reveals an awkward point. Before asking whether reality is simulated, we need to specify what counts as a simulation, what must be preserved, and how the simulated world relates to the machine running it. The simple apartment picture starts developing extra corridors. This is where the modern question connects to a much older one. In the 17th century, René Descartes imagined a powerful deceiver manipulating all his experiences. Later philosophers used the image of a brain in a vat receiving signals from a machine. Before computers, people worried that life might be a dream. The equipment changes. The skeptical problem remains. How can you know that your experiences are caused by the world you think exists? Any evidence presented inside a perfect simulation could itself be simulated. You inspect the atoms and find no pixels. The computer has simulated atoms with no pixels. You receive a message saying, "This is base reality." The computer has simulated a reassuring message, possibly using a tasteful font. A perfect simulation seems designed to match all possible observations. That makes it difficult, perhaps impossible, to test from inside. And a hypothesis that explains every possible result may not function as a useful scientific theory. It can remain philosophically possible without producing predictions. But total skepticism may move too quickly. Philosopher David Chalmers argues that even if we live in a simulation, much of ordinary reality could still be real. Your table would be a real table made from simulated matter. Your coffee would still be hot relative to the laws of your world. Your friend would still be late. The deeper machinery would change what these things are made of, not automatically turn them into illusions. A hurricane simulated badly on a weather computer does not get wet. But if conscious beings live entirely inside a world, interact with its objects, and suffer its storms, then those objects and storms are real parts of their environment. The apartment may be made of information, but the rent can still be due. This also means simulation theory does not erase morality. If simulated beings are conscious, their happiness and suffering matter. Pulling the plug could be mass killing rather than closing a program. The possibility of creators outside our universe would not automatically make them wise, good, or worthy of worship. They might be graduate students. This would explain the neglected corners, but little else. Nor does the hypothesis answer why anything exists. It moves the question upstairs. Who made the outer universe? Is that universe simulated too? Eventually, our apartment building becomes an infinite tower, and nobody knows who owns the land. So, are we living in a simulation? It is possible. Bostrom gave us a serious reason to think about the probability under specific assumptions. Physics can test some specific simulation models, but there is no confirmed glitch, grid, message, or experiment showing that our world is artificial. The broadest version may be impossible to rule out because it inherits the old skeptical problem of distinguishing reality from a perfect deception. Now return to the mug stuck halfway through the table. If that happened, the best explanation would probably not be that reality's computer needs restarting. You would first check the mug, the table, your eyesight, and whether you are still asleep. Extraordinary explanations do not become stronger merely because they are larger and have better graphics. But the simulation question leaves us with something stranger than a yes or no. Even if the apartment has another world above it, this is still the world where our choices land, where pain hurts, where promises matter, and where the coffee is getting cold. Perhaps reality is fundamental. Perhaps it is computed. Either way, it is the only floor we currently know how to live on.